Hello everyone and welcome to this module of the electrician trade. In today's session, we will learn about the design layout of the control cabinet, assemble control elements and wiring accessories for local and remote control of an induction motor. By the end of this lesson, you will be able to draw the control and power circuit for local and remote control of a motor, mark the layout on the control panel, drill and tap for fixing accessories, mount the DIN rail and accessories, wire up the accessories, arrange the wiring by routing, bunching and tying, test the control panel for local and remote control of the induction motor. The required components and tools are one trainee's tool kit, one scriber 100 mm, one hacksaw frame with blade 300 mm, one hand drilling machine 6 mm capacity, one HSS drill bit 6 mm and 3 mm, one round nose plier 150 mm, one crimping tool 200 mm. We will also need one digital multimeter, one mega 500 volts, one contactor 4 pole 16 amps and 240 volts, one thermal overload relay 10 amps and 415 volts, one remote station, one overload relay 15 amps and 415 volts, one push button green and red each, one indicator lamp with holder red, yellow and blue, one MCB 3 pole 16 amps and 415 volts, one raceways, one DIN rail, wire clips as required, terminal connectors as required, wire ferrules as required, grommets as required, lug or thimble as required, cable binding straps and buttons as required, nylon cable ties as required, PVC 1.5 square mm copper cable 660 volts in red, black, yellow, blue and green as required, and assorted size bolts and nuts as required. Now, let us identify the control accessories used for control panel wiring. A 4-pole 16 amps 240 volts contactor provides protection with open and closed circuit specifications. A 10 amp 415 volts thermal overload relay provides protection which senses if there is overcurrent through overheating and sends the signal for opening the circuit. A 15 amps 450 volt overload relay provides protection which senses if there is overloading and sends a signal for opening the circuit. A push button provides control to turn on and turn off the circuit. 3-pole 16 amps 415 volts MCB provides control and protection to turn on and turn off the circuit and turns off during overload. Before we get into drawing and wiring of the power circuit, let us understand the meaning of local and remote control of an induction motor. Local control of an induction motor refers to the control of the motor that is done directly on the motor's control panel, while remote control refers to the control of the motor that is done from a distance, usually through a remote control device or system. Many appliances in our homes use induction motors with local and remote control, such as ceiling fans and water pumps. So, it is necessary to have a control panel for local and remote operation of a single load. First of all, we need to develop the control and power circuit diagram for local and remote control of an induction motor. Draw the control and power circuit and check the correctness of circuits. In the schematic diagram of a control circuit for local and remote control of the induction motor, we have used normally open push button for closing the circuit and normally closed push button for stopping the motor. Remember, when a load is controlled from various places, all the stop push buttons should be connected in series to each other, whereas all the start push buttons should be connected in parallel to each other. OLR or the overload relay to protect the motor from overload currents. Label the terminal number in the control and power circuit. Now that we have discussed how the control accessories are used for the control panel wiring, let us move on to drawing and marking the layout in the control panel. First, develop the layout diagram as per the control circuit developed. Select and check the required accessories. Use a steel rule and scribber to mark the layout inside the control panel cabinet. Mark and cut the DIN rails and raceways according to the layout diagram. Mark the fixing holes and make drills to fix control accessories, DIN rails and raceways as per the marking. Fix the control accessories, raceways and DIN rails using screws and bolts. Finally, mark and use drills to make the necessary holes in the door of the panel for the indicator lamp, push button and wire clips according to the markings. Let us now wire the control and power circuit for local and remote control of the induction motor. Fix the relay contactors and other accessories in the appropriate position in the control panel cabinet. Measure and cut the cable as per layout. Insert the ferrule numbers at both ends of the terminals as per the layout. Leave some extra length of wires in the raceways for easy maintenance and repair. Run the wires in the raceways one by one. Avoid the crossover of the wires. To avoid the crossover, the vertical wires can be run followed by the horizontal run. Skin the wire ends and crimp with suitable lugs or thimbles. Connect the control circuit and power circuit wiring as per the circuit diagram. Avoid the loose connection and over tightness. Route the wires in the raceways. Punch and tire the wires in the raceways using cable binding straps and buttons. Cover the PVC raceways over the wiring. Take necessary care to avoid the crushing of cables when covering the raceways. Make the U-loops of wires in the hinged doors. Bunch and tie the cable in the doors. Fix the wire clips at suitable places to hold the cables in the panel door. The U-loop should not disturb the movement and closing of the panel door. Connect the incoming and outgoing terminals as per the diagram and terminal details. Use the grommets to avoid the strain on the cables. Earth the panel and door and metal devices. If multiple piles of earth are used, use common earth terminals and strips. Measure the insulation resistance of the panel. If the IR value is less than 1 megaohm, take suitable remedial action. Set the OLR in accordance with the full load current of the motor. Now, let us test the control panel for local and remote control operation of the induction motor. Before switching on the main supply, we first need to check whether the control circuit works properly or not. So first, switch on only the control circuit supply. Now, press the remote start push button and see whether the power contactor gets pick up or not. Then, press the remote stop push button and see whether the power contactor drops or not. Similarly, check the start and stop push buttons operation from local push button station and ensure that the contactor pickup and